All right, this is 5.2 recap, stuff we talked about in class about direct variation. Now, a couple things we're looking at is just trying to wrap our head around direct variation and when that shows up. And we talked about this, the time thunder takes to hear, the time it takes to hear thunder varies directly with the distance from the lightning. So as the distance changes, the time to hear it changes as well. There's a couple examples. You guys thought that these weren't really great examples. I could tell by the moaning in your voices, but I think they're pretty close. But you're right, there are some things that don't make these always true. Here's some of the notes we talked about. And when we're looking for direct variation always shows up in this form, y equals kx, so that if you're adding or subtracting anything on the end, if you have a constant showing up, then you are no longer looking at a direct variation. And you can play that out like an A and B. You go ahead and do your operations, move everything away to isolate y, so you get y equals, and then you can tell like an A there is no constant, so this is indeed a direct variation, but it does have a constant of variation. So really my equations have a couple different things. This one, though it doesn't have a constant, it does have a constant of variation. Same with B. This one does have a constant of variation that we found, but it also has a constant, which means there is no direct variation on this one. This is one we actually didn't talk about a whole lot, but you can go ahead and solve for k by plugging things in. If I know y equals kx, in this case y is 35, k is what we're solving for, and we know that x is 5. I can go ahead and divide by 5, and I see that k equals 7. So now I can come back to my original problem to try to find out when, now that I know what k is, I can now find out the value of y when x is 9, because I can still use my same formula, y equals kx, but in this case, I know what x is. X is 9, and I do know what 7 is, so I can plug it in. Y equals 7 times 9 upside down. 7 times 9, so y equals 63. So when x is 9, y is 63. Get a chance to do that. Using word problems, a lot of different ways to solve these. I know many of you were working on just using the ratio, but remember we were trying to find our k, trying to find our direct variation, and we can find that by building a ratio. Really, it does show up at slope. So we looked at a relationship between weight on Mars and weight on Earth, and you can see from our work that it does play out very well. And a couple things that we needed to keep an eye on, I believe it was in one of the slides on independent variable. Well, I'll talk about when it shows up, but so it's okay. Graphing, we can tell when it's a direct variation because it goes directly through the origin, as somebody indicated yesterday, and that was really cool. Pass through 0, 0. The slope line is k, and there is no constant, nothing being added or subtracted on the end. We found if there is a direct variation in a table by looking at the ratios, y divided by x. Okay, rise over run and check the ratios. If they're consistent, there is a direct variation. If they're not, like in B, then there must be a constant in there, kind of throwing this off a little bit, but it is not does not have a direct variation. We tried some more problems and with the idea of using our equation here and finding our ratio for k. The tricky part about these ones is just building them the correct way and just remembering to build it as y over x, where x is your independent variable. So when you're looking at a story, you're trying to figure out what depends on what in your particular story. And if you know what depends on what, then you can build your ratio of y over x. All right, I hope this helped out. All right, I'm going to go and ride a goat until I can't stand the smell of it anymore.